Welcome to this tutorial about sketching lines in a given domain. Now, when sketching lines, sometimes it's necessary to restrict the graph to a certain domain or to a certain range. Depends on the question, of course. So what I mean by that is if we once again have an axis, I'll draw a bit of a wonky one here. Okay, so let's say we have this axis and we've got X and Y. Now, unlike before, where we explored lines that go on forever, and we had little arrows here on each of the ends to indicate that they're going on forever, certain linear functions and certain, not just linear functions, but parabolas, cubics, etc., they can be restricted to a particular domain. Now, maybe for a modeling sort of question, you might just need to explore the linear graph from, say, this point in a application question, from this point here all the way up. So now you have actually restricted the domain. You've also restricted, so the domain looks at the X values. You've also restricted the range because there is a whole lot of Y values that are not there anymore. So you can say that you've restricted the domain, or you can say that you've restricted the range. Both are interrelated. Now, so when you're actually sketching graphs in a particular domain or range, it is necessary to perform the following steps. So the first step is a really important one, and that is to find the coordinates of the endpoints. Now, the endpoints are, where a linear graph starts from and looks at where it ends. So say we had this linear relationship here. This would be one endpoint here, and that would be another endpoint. And so that might be, say, -5 and 8, and that other coordinate here might be -1 and 2. So those are the two endpoints. I just made this example up completely, but they are endpoints, so where it starts and where it ends. So very important consideration in a sketch that has a specified domain or range. And of course, just like before, these steps should be familiar to you. Finding the x-intercept, finding the y-intercept. So finding the x-intercept by let y equal to 0, and then finding the y-intercept by letting x equal to 0. So we've got our three steps here. Now let's have a look at some of these examples. So these are off the worksheet. Now what I'm going to do is I'm going to just select a few of these questions, so about 6 of them, that we can work together. Whoops, use this. So I'm going to select 6 examples. So let's say we will select this one here, maybe D, and let's say, okay, we can take C as well. And then from question 6, we might do, let's do question C. Let's do question D and question F. All right, so in order to do these questions, you have to be familiar with interval notation, set notation. So I would recommend exploring that concept, those concepts. If you are not familiar with them, please go back to a previous video and just refresh your memory. I will be assuming that you know sort of what each of these symbols means, like R plus and the open bracket and the closed bracket, but I will be trying to refresh your memory as we go through this. So let's have a look at how to do this one. So question B. Question B says that we're trying to sketch a function. I'll write it up here. So f -2 to 4. This is just the codomain here. We don't really need to worry about it too much, where the function f(x) is actually just equal to 3x. Whoops, I think I wrote the wrong function. Yes, I did. 5 minus 1. 5 minus x, sorry. Okay, so let's have a look at how we would sketch this particular function. So once again, we have to follow our 3 steps. So we know we have an additional step that we need to take, and that is to find the endpoints. So we'll start off with step 1, find endpoints. So we find the endpoints. We know that the domain here's our domain, and there's a restriction. So x, the minimum x value, x minimum, is equal to -2. And then we have the x maximum value, which is equal to 4. And remember that the brackets, the x minimum value is not included in the sketch because it's a circular bracket, and the x maximum value is included. So finding the endpoints, now all we need to do is we need to substitute those 2 values into our function. So I'm going to replace into our function, I'm going to put -2, and we know we've got 5 takeaway, put in -2. That's just using this formula here, where now I have a value of -2, and what I place into that bracket, I have to actually change in the equation, which is why I'm putting in -2. And so when x is -2, we get the minus and a minus make a plus, and we get 7. Now for our x maximum value, once again, we just substitute in 4, and we get 5 minus 4. F of 4 is equal to 1. And so our endpoints, we write up endpoints as coordinates. So the x minimum value is -2, and the y value that resulted is 7. And then for this endpoint, the value is 4, and the y value is 1. And so what I'm going to do is I'm straight away going to sketch those 2 points out. Because there are 2 points, you can probably already connect those 2 dots and form a line, but we still need the y and x intercepts because they're important for our sketch. So I'm just going to find -2 and 7. So -2 and 7 look like they're about here. Now, I've just made a mistake there because closed dot means that I have included that point. So I need to get rid of that closed dot, and I need to maintain a open dot, and I hope that that doesn't cause problems. So -2 and 7. Okay, so that's my open dot. Okay, I'll make it nice and clear. And so that's 7 there, and that's a -2 down there somewhere. Yep, perfect. So we've got it drawn. Now we've also got to draw 4 and 1. 4 and 1 look like it's about here. Okay, so we know we have those 2 points. We could just join them together now, but I'm going to go on to step 2, which is find x-intercept. Let y equal to 0. And so y is actually fx in this case. So all you have to do is just 0 equals to 5 minus x. Move the 5 over to the other side. You've got -5 equals to minus x, and then x equals to +5. And though I just realized that I made a little bit of a silly mistake, because I can see from this sketch, I can see that the line is not going to actually be able to cross the x-axis because it's outside of the domain. So even though it's good that I found that, it's probably not going to be helpful for this problem. So I'm going to find the y-intercept, and that one will probably be important. So let x equal to 0. And so we're just going to put f of 0 equals to, replace the x with a 0, and we've got 5. Whoops, don't know what happened there. Okay. I'm just going to adjust some of the settings here because it's not cooperating as... Alright. Okay, so it's equal to 5. Now, that means that on our sketch, this is an important feature. And now I will be trying to connect those two lines, those 2 points together. So it looks like something like this. Okay, so that's now we have to label our coordinates and our endpoints. So you have to have -2 and +7 there. Down here we have 4 and 1. And right there we have 0 and 5. Okay, so we didn't need the x-intercept because we are actually not going to be crossing through the axes at all, because the point at which we stop is right here. And so we're never going to cross the x-axis, so there's no point in finding it. Okay, so moving on to the next question. Which question did we decide on? Okay, so question C. Now, let's have a look at whether I can remember this. So F positive, R positive, okay. I will, in the next video, actually write these out. So F R positive to the codomain of R, and then Fx being equal to 3x plus 4. Okay, so now this will test a little bit of your understanding of what R positive stands for. Now, again, we're going to have to find the endpoints, but before we do that, you have to know what R positive stands for. So remember, this means positive real numbers. And it's not including 0. If you wanted to include 0, you would have to say something like R plus and 0. Like so. So we can rewrite this problem and say, okay, well, the graph has to extend from 0, but not including 0, all the way to infinity. So this is really what we mean in the question. So it's not inclusive of 0, so I have 0 with an open bracket, and we're going all the way up to positive infinity, so I need to put a circular bracket around infinity. And likewise, we have to, as before, we have to find endpoints. Just like before, except with the infinity, it's going to be a bit different. We're just going to ignore the infinity. I'm just going to have a continuous arrow on that part of the line. But let's just substitute in 0. 3 times 0 plus 4. So f of 0 is equal to 4. And so one of the endpoints is 0 and 4. The second thing that we probably need to do, so I might find where that point is. So, and I'll keep an open circle right there. Okay. Once we've done that, this is a positive line, so it goes on for, you go from left to right, it goes upwards. So we need probably another point to sketch an accurate graph. Now, we're not going to use infinity because we're just going to get 3 times infinity plus 4, which is still infinity. So I'm not going to use infinity. What I will do, though, is I might just substitute another random point into our equation here. So sub in I'm just going to choose another value of x. So say x equals to 1. And the reason why I'm not finding the x-intercept is because this graph is actually going to be going that way. It's not going to be going that way. And so there won't be any x-intercept, okay? So very important to understand that there actually won't be an x-intercept because the graph begins from this point here. Okay, so when we substitute in x equals to 1, we go f of 1 equals to 3 times by 1 plus 4. And that's 3 times 1 plus 4 is 7. So I know now that when x is 1, which is right down here somewhere, the y value, the corresponding y value is 7. So 7's right there. So those are our 2 points. And now what we need to do is we've pretty much finished the problem. We just need to use a, okay, not a very good graph there. All right, I'm going to get rid of that, delete it. I'm going to try again. We're going to start from this point here, and we're going to move through that point there and keep going. So now, because we have 2 points, we've actually defined the gradient. So I'm just going to provide the coordinates for this point. So this point here is 0 and 4. And that point there, that coordinate there is 1 and 7. And so now, since we have 2 points defined on our line, that's all we really need, 2 points. You don't need to find any more than that. So it's quite a tricky question because it was a little bit different to the steps we've taken before. There was no point in finding the x-intercept. Okay, let's have a look at the next one. So we've got G are excluding -1 to 3. Oh, this is one that I will not remember. So, okay. G, all real numbers excluding -1 and 4 to R, and Gx happens to be, I think it was 1 minus 4 over 3x. Let's see if I actually remember that. I don't know where the 4 came from, but apart from that, -1 up to 3. Yeah, it's almost there. Okay, so it's actually only up to 3. Okay, so once again, we've got a particular domain which we're going to have to restrict towards, and our domain in this case is looking at all real numbers except the region between -1 and 3. So the domain is all real numbers except the region between x equals to -1 and x equals to +3. Now, so everything apart from the region between -1 and 3 is inclusive. So -1 is here, and 3 is there. So we're not going to have any linear function between those 2 points, but everywhere else it will be fine. Now, what I'll do is, once again, I'm going to find endpoints. And so we're going to say, okay, well, the x minimum value possible is -1, and the x maximum value is equal to 3. And so we need to substitute it into our formula, x minimum of -1, put it in. One plus 4/3, and that's 7/3. And then we have the x maximum value, where we have to replace this with 3. So 1 take away 4/3 times by 3, that and that cancel, and you get 1 minus 4, which is -3. Okay, so our endpoint so far, we've got -1 and 7/3, and we have 3 and -3. Now, one of the things that we need to consider here as well is that this symbol here means except. So all real numbers except. And then we're actually not including -1. So when we go up to -1 and 7/3, where's 7/3? It's somewhere here. We need to decide whether that's going to be an open circle or a closed circle. Now, we are not including -1 in the exception. So actually, the point at -1, at x equals to -1, will be inclusive in the sketch. I'll repeat this again in a moment, but basically because we are excluding, sorry, this is very confusing. So we're not including -1 in the exclusion. We're not including -1 in the exclusion. So we're actually graphically including it. So it's always just the opposite. Whenever you have an exclusion sign, these brackets actually change in the actual sketch. So if we go to x equals to 3, and we know that the y value is -3, so it's down here. Let's have a look back at what we're doing with the domain. So it says all real numbers except the inclusion of 3. So as a result, we have to just keep an open circle. Okay, so it's actually the opposite of what is intuitive to us. And now the two graphs that you can see, if you were to sketch this, you could see that there would be one section of the graph going sort of like that way. I'm going to fix this up in a second. And one section of the graph going that way, but nothing in between those two regions. And so in order for us to find a more accurate sketch, once again, we have to find, there's no point in finding the intercepts. We have to find two more coordinates. So what we do, I'm going to choose possibly an x value of, say, 5. So if +5, substitute it into g of x. G of 5 equals to 1 take away 4/3 times by 5. 1 take away 20/3. And 3/3 take away, so -17/3. So we've got -17/3, which is just around 6. It's very close to 6, so we've got a point there. Now we also have to do the same to the section of the graph on the other side. Okay, so I'm just going to get a little bit more space. I'm going to try to squeeze it in here. So I might choose a coordinate, an x value of, say we'll just choose 2, -2. So we've got 1 take away 4/3 times -2, and that's equal to 1 plus 8/3, and that is 11/3. So 11/3, that's almost 4 when x is -2. Y value is almost 4, so it's here. All right. So now all we need to do is we just need to connect those with appropriate lines. Whoops. What was that? That's not what I asked for. I'm not sure what it's doing. Oh, delete what I need. Okay, so I'm going to put that point back in. So we had a point here, I believe. It was somewhere there. Yep. Okay. And so I'm just going to try that again. Oh, it's doing something really strange. Okay. If I dare, I'll put it here. Okay. Okay. You know what? I'm going to try to draw it by hand. So we've got this point here, and we've got this point here. See, this is why I use the ones that are pre-made. So we need to include the endpoints, the coordinates of the endpoints. So this is -1 and 7/3, and this is 3 and -3. Okay?